Let's delve into an overview of Amazon Route 53, a key component in the AWS suite. Route 53 is a managed DNS, which stands for Domain Name System. But what exactly does this mean? In the context of AWS, Route 53 manages several common types of records. Let's go through a few examples to understand this better. First, we have the A record for IPv4 addresses. This is where a domain name, like www.google.com, is directed to an IPv4 address, say, 12.34.56.78. It's one of the most fundamental types of DNS records. Next is the quadruple A record for IPv6 addresses. Similar to the A record, but it points to an IPv6 address, like www.google.com, directing to 2001.0db8, 85A3, 0000, 0000, 8A2E, 0370, 7334. This is increasingly important as the world shifts towards IPv6. Then we have the CNAME record, which stands for canonical name. This type involves mapping one domain name, like search.google.com, to another domain name, such as www.google.com. It's like creating a nickname for your domain. Lastly, the alias record in AWS is quite unique. This allows you to map domain names, like example.com, to AWS resources. These resources can include services like Elastic Load Balancers, CloudFront distributions, S3 buckets, or RDS instances. Let's walk through this diagram to understand how an A record DNS request works in the context of Amazon Route 53. Our journey begins with a web browser, which initiates a DNS request. This happens when a user types in a domain, like myapp.mydomain.com, into their browser. The browser needs to know the IP address associated with this domain to establish a connection. This DNS request is then processed by Amazon Route 53. Route 53 acts as the authoritative DNS service. It looks up its records to find the corresponding IP address for myapp.mydomain.com. In our case, it finds the A record, which is 32.45.67.85. This is an IPv4 address that Route 53 sends back to the web browser. Once the web browser receives the IP address 32.45.67.85, it proceeds to send an HTTP request to this address. The browser includes the original hostname, myapp.mydomain.com, in the host header of this request. This step is crucial for reaching the correct application server. The application server, identified by the IP address 32.45.67.85, receives the HTTP request. It recognizes the host header and processes the request as coming from myapp.mydomain.com. After processing, the server sends back an HTTP response to the web browser. In this entire process, Amazon Route 53 plays a pivotal role in translating human-friendly domain names into machine-friendly IP addresses. This not only facilitates the ease of accessing web applications but also ensures efficient and accurate routing of internet traffic. Amazon Route 53 offers diverse routing policies to address different needs and scenarios. Simple routing policy. This is the most straightforward policy. When you use simple routing, you can route traffic to a single resource, like a web server. It's ideal for cases where you have a single resource that performs a given function for your domain, like one web server that serves content for the www subdomain. The weighted routing policy allows you to assign weights to your DNS records, which helps to manage the distribution of traffic across multiple resources. For instance, if you want to route 60% of your traffic to one server and 40% to another, weighted routing makes this possible. This policy is particularly useful for load balancing and testing new versions of software. The latency routing policy helps to route your users to the resource that provides the lowest latency. This means if you have resources in different AWS regions, Route 53 will respond to DNS queries with the IP address of the server that has the lowest latency relative to the user. It's ideal for ensuring a faster response time for your users. The failover routing policy is designed for high availability and fault tolerance. It allows you to configure active-passive failover, where Route 53 will route traffic to a primary resource, like a primary server, as long as it's available. In case the primary resource fails, Route 53 automatically routes traffic to a secondary resource, like a standby server.